Greetings and salutations and welcome to another Inventor video. In today's video we're going to do the beginner's guide to the assembly environment. So if you just go on to assembly and it loads up. And you welcome to this whole new environment which looks a little bit strange if you've never made any parts, but ultimately assembly mode is there so you can put your parts into one full functioning product. And yes, you go to sub assemblies that go to main assemblies and you can have multiple different layers. But overall that's kind of more of a file hierarchy kind of thing, whereas this is just going to be an overview. Now this is going to be for beginners, so if you have some experience, this is probably not the video for you, and maybe not really the series, because this toolbar series is meant to be for beginners by someone who's been in that position fairly recently. I've had 4 years of experience with Inventor, really 2 of which were really basic and not following any kind of convention, just free-forming it, whereas the last 2 have been a bit more serious and more learning about Inventor. So without further ado, let's get back into the assembly environment. So if you notice, we now get the Assemble tab. And the Assemble tab, well, it gives you kind of just a short down list, but you get Place, which if you notice is a whole different tab down here. If you can see my hand, it was gesturing down. Place from Content Center, Place import CAD files, Place iLogic, and Electrical Catalog. Place is any IPTs. Content Center is things like screws, bolts, washers, standardized stuff. Import from CAD, so these are not your non-IPTs, and iLogic is all your iLogic components. Create is specially designed to make parts in the actual assembly. These are quite good for skeleton solids when you want to go and do something like the frame generator, which we'll come into a bit. And you want to make stuff in there that doesn't really need to be a part, but it's more there purely for reference. So if we go to a part, as you see here, I've got nuts, I've also got gears, so let's just go and grab, oh, I don't know, grab this copper nut. And you see, I can place them all around here. You can place them multiple times. Now I've got something in here, you get free move and free rotate. Free move does what it says on the tin. You can grab it and you can just drag it around. Free rotate, just select it and you can freely rotate it. Nothing really that special. You just got to make sure you're actually on the right axis to it. But let's return back to that. Right, okay. Joints and constraints. We'll go to first we'll actually touch on constraints because they're probably the most thing you'll come to. Joints we can do as separate. Constraints are purely static. Well, they can be more dynamic, but mainly static. And with the constraints, you've got mate, angle, tangent, and inset, and symmetry. Most of the time, mate is probably one of the most common used, but you can literally just select a face, and they'll just stick together. It's like you just added glue. And you can click apply, that leaves it open. Grab a side, click apply. Now whatever you do, they're pretty much now stuck together. It's pretty simple. And obviously then you've got show glyphs, and hide glyphs. Now obviously with the assembly environment, you can pattern mirror copy. If you want to go see that, I have a pattern video for 3D, but it's very much the same concept here. Bill of materials, or BOM. BOM is basically a parts list, and you can literally just track everything. You open it up, and I've managed to place 9 nuts. But this allows you to track it, and you can also see parts within assemblies and sub-assemblies, and you can also change the BOM structure. BOM structure becomes more important when you're starting to work with references, ghosts, what are called ghost parts, which are more there just for the actual structure of points rather than actual functional part. They're just a frame for you to build around. But obviously I've only got nuts here for quantity, and obviously you can add descriptions, etc, etc. Parameters. These just allow you to customize parts, change them, scale them up because it's all parametric. Derive substitutes allows you to drive parts as you would like with a normal part and adjust it. Plane axis points as standard. And shrink wrap really is about removing details, so if you want to send it off to a dealership but you don't want them to have all your intellectual property, you can do that. And measure does what it says on the tin. That's assemble pretty much as fast as possible, and we're going to briefly touch base with design. Design is all about, there are some specific things in assembly that we get, like multi-connections and the frame generator. The frame generator is especially useful, so if you build stillages or actual frames or tables or anything where you can just use standardized materials or bars or square blocks, whatever, you could do it in here. And then obviously you got some more analytical tools, springs, you can make your own bearings and gears. But other than that, 3D model, very similar, just less of it. Right, so that's all really for the assembly, in a nutshell. Obviously I'll go into a bit more detail on some things like frame generator, clevis pins, bomb structure, and joints later on. But thank you for listening. I'll see you in the next video. Goodbye.